Welcome to today's lesson. I'm Siamsaka Krendens. So I'm going to take you through a lesson for today. So we go straight to the lesson. Well, today we are going to look at mass. As we may be aware, mass can be defined as the amount of matter in a body. Amount of matter contained in a body is what is known as matter. The SI units or international units which are used to measure mass is actually kilogram, abbreviated kg. Well, mass is a scalar quantity because it is only measured using the magnitude, which is also known as the size. It has the same value in all locations because it's merely a quantity of matter. And so, in some way, mass is related to inertia. And inertia is actually the property of a body that makes the body to tend to remain at rest or maintain the state of motion. And so, in essence, what we are saying is that a body at rest would actually tend to remain at rest. A body in motion would tend to actually remain to maintain that motion. In some way, inertia can be described using Newton's first law, which states that actually an object at rest remains at rest, and an object in motion remains in motion unless this object is acted on by an external force. We can actually apply inertia in different ways. One familiar way in which inertia is applied in our day-to-day life, or where actually people experience inertia, it is actually people traveling as passengers in cars. What happens is that when a car stops, the passengers are thrown forwards. The main reason is actually the effect of inertia, because actually the passengers, when they are in a car, they tend to maintain the motion of the car. And if abruptly the car stops, then they remain in that state of motion while the car actually has stopped. And therefore the passengers will tend to be thrown forward. Another scenario in which actually inertia can be applied is a situation where a car actually accelerates. And so the passengers who had maintained a state of motion, when the car actually accelerates, it means that it will have a different motion, and therefore the passengers will be thrown backwards. And so this is the application of actually the state of accelerating a car while the passengers remain with a different motion. The other application of inertia is basically on an object which is heavy. For example, a 90 kg bag in motion, it is actually difficult to stop it and also difficult to put into motion. The explanation is actually because of the state of inertia a heavy object has. A heavy object actually has greater inertia, and as such, when it is in motion, it is difficult for actually a person to stop it. And if it is at a state of rest, a large body with a large inertia will tend to be very difficult to be put into motion. And so mass can be used to be measured, actually can be measured using the familiar apparatus known as a triple beam balance. A triple beam balance actually is made out of a pan where actually the mass is placed, which is supposed to be measured. And ideally, it has a pointer which should always, before actually measuring, coincide with the 0 mark on the other arm of the beam balance. And so it has, at times, 3 scales. There is scale 1 there is scale 2 there, and there is scale 3 there. For example, scale 1 has these measurements: 30 to 100 grams. Scale 2 here, 0 to 500 grams. And scale 3 is actually 0 actually to 10 grams. For example, if we put a mass and this mass in the middle comes there, it means that we are going to have 350 grams at that point, because this is the middle of 300 and 400 grams. And if the other mass is actually at, say, 30, it means that that one will be 30 grams. And the other weight maybe is at the 3 grams mark. So it will be 3 grams. And so we can add all of them, and it will give us 3, 8, 3. So 383 grams. And so you move these masses until the pointers here actually balance. And so when you are actually taking the masses or measuring mass, there are precautions you need to take into consideration. One of them is that the weights should not be held with actually hands, but they should be held with forceps, because if, for example, your hands contain certain particles, they can be deposited on the weights and they contribute to the increasing mass. And also, the masses should always be made dry and not hot. The weights should also be put in a box after use so that they do not affect the accuracy of the triple beam balance. Because if they remain there, they are actually exposing the triple beam balance to those weights even when they are not being used. Similarly, when you are approaching the near weight that you are actually measuring, you should ensure that actually the weights for them to have a coinciding pointing to zero, they are actually tried in the descending order. And so I thought today we can look at mass, and those who want to actually contact me, they can contact me if they want one-on-one lessons on this WhatsApp number +260 977 419949. Then I can give them a feedback on how we can arrange for one-on-one lessons. I thank you.